Think we'll get started now. Welcome, everybody, to today's GlobusWorld pre-conference session. My name is Susan Tussey. I'm the communications manager here at Globus. And I think we'll go to the next slide, Bridget. So first off, we certainly want to thank our sponsors for GlobusWorld. We really appreciate their support of this conference and really value their partnership. What we want to get started with is just to show you the agenda for today. So we really have two sessions. The first one is the introduction to Globus for researchers and new users, which Bridget Rahman and Greg Noraki are going to be leading. And we will then have a break before we get into the next session. We know this is a rather long webinar, but hopefully you can stick around for the whole thing. But the first one is from 10 to 11:30 Pacific, or sorry, Central. A little early. I need a cup of coffee. Um, and with that, do want to point out that you can enter things into the chat and or raise your hand. We want to make this actually as interactive as possible and as worthwhile for you as possible as well. So please don't hesitate to either raise your hand and we'll unmute you or enter your questions into the chat. So with that, maybe Bridget, you want to get started?
Sure, I get started. All right. So as Susan said, I'm Bridget Rauman, and Greg and I are going to give you an introduction to Globus. The introduction is really going to be targeted to new users, so users who've never used Globus and maybe don't even know exactly why or how they would use Globus. Um, but before I get into how and why you use Globus, I'm going to just spend 3 minutes putting the Globus project and the Globus team kind of in perspective or in context so you guys know where we're coming from. So, Globus started as a research project many decades ago now by computer scientists at Argonne National Lab and the University of Chicago. And their mission really was to meet some of the challenge they were seeing that um, were emerging because data was becoming much larger at that time than their colleagues were used to, and they were having trouble managing. And also importantly, data became distributed at that time. So now research data was stored across many different systems, and that was a new challenge at the time. Uh, so it started, as I said, many decades ago. Fast forward to the present. Globus is no longer a research project. It is a sort of professionally developed and operated service, but it's developed and operated as a nonprofit service out of the University of Chicago. So the entire team is at the university. Globus isn't a commercial product or an LLC or some kind of spin-off of the university. We are just a unit at the university in our Office of Research. So, and our mission remains the same, and that is to enable researchers, particularly researchers engaged in sort of data-driven science and scholarship, to just meet those challenges of managing their data so that those mundane problems that can be solved by technology can be overcome quickly so that they can get to the business of actually performing their research. And our mission is to do that through sustainable software. And I've emphasized sustainable here in this slide because it really is an important part of our mission that we take very seriously. It's important for us for that we will be around in the next 10 years, 20 years, in part because a lot of cyber infrastructure relies on Globus, national infrastructure, perhaps your campus infrastructure. So we really focus on being sustainable. And we do that in two ways. One is we are funded by grants in part. So I want to thank our funders. And what's funded by grants is the new development, the innovative development, for perhaps maybe adding new capabilities, entirely new services to Globus that have never been offered before. So that's the really innovative, cutting edge projects, and those are often funded through grants. Uh, Grant funding is not a ideal way to support things like software services operations, software maintenance, and even development of features and enhancements of already established software. So that incremental improvement is not often funded by grants. And so we have a freemium subscription model in order to sustain that portion of effort by our team. And that model is, as I said, it's freemium. So the core services of Globus are free to anyone engaged in nonprofit research. But there are some premium features that if an institution wants to offer that to their members, they can subscribe to Globus. So they can, there's an annual subscription fee for everyone at the institution to access those premium features. So I want to take this second to really thank our subscribers. They are what sustain us, and they're not just what sustain us, but they are really what allow us to thrive as a team, as a project, as a software offering. They allow us to continue to improve the software, continue to add new capabilities. So it's really thanks to our subscribers that we're thriving, and also thanks to our subscribers that we have reached the wide adoption that we have. So Globus is widely adopted, certainly at academic research institutions across the U.S., but not just the U.S., across the whole globe. Um, we are also used at a variety of different types of institutions, research institutions. So I mentioned academic research institutions, but also our national labs use Globus. Federal agencies, a number of federal agencies that are engaged in research use Globus, independent research institutions. So a variety of different types of organizations use Globus, and a variety of different types of science and scholarship are enabled by Globus. So Globus is not specific to any one research topic or even field of research. So it's used in the life sciences, anywhere from structural biology to cell biology to human genetics. It's used in the physical sciences, for example, chemistry, materials sciences, cosmology. It's used in the social sciences and even in the digital humanities. Okay, so I hope that gives you some context for the project and for the team. I'm going to focus the rest of my talk on the technology. So what does Globus do, and how would you use it? And I'm often asked, what's Globus? And that is, I find, a surprisingly difficult thing to answer. I always think of that elephant that is different to everyone depending on where they're touching it. Globus is a lot like that too. It really depends on how you're interacting with it, where you're touching it, what it means to you. As I said, this is targeted to the end user, to a researcher who might want to use Globus, and so that's what I'm going to focus on. And so from that perspective, right, Globus is a way that you can move your data, a way that you can access your distributed data, so unified data access, a good way that you can share your data, but not just transfer and sharing, which probably most of you know Globus can do, but also there are many other capabilities of Globus. So for example, you could use Globus to publish your data, right? We have tools to support creating science gateways or data portals. We have tools that help you create a convenient way for people to search for your data and find your data. We have services that allow you to execute functions across the variety of compute resources that you might have access to. And we have ways where you can automate all those data flow tasks that you do over and over again. We support automating those so that you don't have to spend time manually doing those each time, and you're assured they will be executed reliably. So I'm going to talk in my the first half of the conference. I'm going to really focus on these core features. And by the way, interrupt, I don't unfortunately see the Zoom video, so just interrupt if anyone has questions. That would be great. So I'm going to focus on these core capabilities, that is transfer and sharing. Greg will then talk about some of these other capabilities, and he'll touch on all of these that I've mentioned. The one capability that isn't depicted here is really the glue that glues all of these services together, and that's our authorization and authentication service, Globus Auth. Okay, so let's start. I am just going to start very simply by focusing on transfer and unified data access. So let's talk about why you would want to use Globus to transfer data and when you might want to use Globus. So moving research data has some somewhat unique challenges sometimes. Right. And Globus serves to overcome some of those unique challenges. So, for example, research data, it's often a large amount of data, either very large files or lots of smaller files, but it can easily be terabytes, hundreds of terabytes, even petabytes, right? And that can be a challenge to move. Location is another challenge, right? Your data is probably not all in one place. And it's also probably not all in one type of storage, right? You very likely have data perhaps in the cloud, on your laptop, at your campus computing storage that's offered to you, maybe at a national resource, or maybe even in a tape archive. And so moving data between all of those different types of storage systems isn't trivial. Each one of those systems has their own interface. They don't necessarily talk to any other kind of platform. And so you um, might need a lot of IT expertise to understand how to move data between, let's say, S3 and your campus tape archive that you don't have. And so Globus overcomes that challenge for you. There's also the challenge more and more that research data is sensitive. It's certainly valuable, and so you want to secure it. You want to make sure you're moving it securely. It also can have regulatory requirements, right? For example, if it's PHI, HIPAA regulated data, that you need to make sure you comply with when you move the data. So those are some of the challenges. And so how would you use Globus and how can Globus help you overcome those challenges? So I'm going to use a very simple use case that I think illustrates, it's a very common use case, and I think it's quite analogous to a lot of the other use cases for data transfer for Globus. So the use case I'm going to illustrate is I'm a researcher. There's data being generated either by me or for me at an instrument. And this could be any type of instrument. This could be an imaging machine. It could be a cryo-EM machine creating videos. It could be a telescope collecting data. It could be a DNA sequencer. Doesn't really matter. The fact is, there's an instrument, and near the instrument, there's some storage, a little bit of storage, and that data is getting written to that storage. Now, the researcher wants to access that data right away, as fast as possible. And there's also very little storage at the instrument, so you need to get that data off of the storage, off of that storage at the instrument for a lot of different reasons. And a researcher wants to move their data from the instrument to anywhere that they have compute resources. Where are they going to analyze that data? Is it going to be at their campus, on their laptop, at a supercomputer? Again, it doesn't really matter. They generally want to move that data off the instrument to wherever they're going to do the analysis. And they want to do it quickly and securely and reliably. And that's where Globus comes in. So let's just walk through step by step how and why you would use Globus to do that. Okay, so here's our researcher. Here's the instrument that's producing her data. And is her compute facility, and whatever that might be. That might be credits in Google Cloud. That might be her HPC center, could be a supercomputing center. Doesn't matter. The point is you want to move your data from point A to point B. How would you do that using Globus? So the first thing you do, you'd open your laptop, you might open your browser, and you would log into Globus and the Globus services. And the Globus services are hosted services. They happen to be hosted in AWS, doesn't matter, that's irrelevant. Um, they're hosted service, so you can log into Globus through the internet. And when you log in, you don't need to create a Globus account. You don't need to create a new username and password. You can use your campus or your institutional identity to log in, and we recognize over 2,000 institutions that you can select from to log in. So you log in, and then you submit the transfer request to the Globus services. So you tell Globus, okay, I want to move my data that's sitting here on the instrument to my folder in at my compute center or my S3 bucket, what have you. And that's really all you need to do as a researcher. Then you can close your laptop and walk away. And in the meantime, you're not worrying about tuning performance parameters, for example, because Globus is doing that for you. You're not worrying about monitoring the progress and making sure everything is progressing smoothly because Globus is doing that for you. You're not worrying about resuming the transfer. If there's some network interruption or some kind of interruption that pauses the transfer, you don't need to be aware of that and go back and resume the transfer. Globus will do that for you. You also don't need to worry about data corruption during the transfer. Globus ensures that the data that is landing on the destination is identical to the data at the source. So all of those things that I've just mentioned are trivial if you're emailing a spreadsheet, but if you're moving research data, particularly large amounts or even small amounts of data, all of those things I've just mentioned are very important. And Globus takes those worries away from you when you transfer with Globus. The other thing I want to point out here is this idea of direct data movement. So you'll see here there's this dotted line which depicts or represents sort of communication between the Globus services and that storage system. So this is just communication over the internet with that storage system, telling that storage system who you are and what you want to move and where you want to move it, um, or in this case, where the data is going to be coming from. Um, but the data itself, those files move directly between the two storage systems. That's the solid arrow here. So there's a direct connection between the two storage systems, and that's where the files move. They don't move anywhere else. They don't move up to our service, and then back down, even transiently during the transfer. So you never disclose the contents of your files to Globus. So we never see those. We never access those. So there's a direct transfer. Which is nice, especially when you're talking to your security team about why you'd want to use Globus and the advantages of using Globus. That is one big advantage, is that you're not disclosing that data to a third party. Um, okay, and you also get a unified view of your storage with Globus. And what do I mean by that? So I mentioned, right, you likely have data across many different types of storage, and each of those has its own ways of authenticating and its own ways of accessing the data. And if you use Globus, you don't need to be aware or care about any of those. You have a single interface. Um, that is the Globus interface, and you use that interface to access all of that data wherever it's whatever kind of platform it's on. And so you only really need to know the Globus interface to move data, let's say even from S3 to Google, for example. Whereas if you didn't have Globus, that would be a sort of an adventure in figuring out how to authenticate to both S3 and to Google and how to get those two systems to talk to each other. So a unified data access. How is that actually enabled? How does that work? So the key to all of this, really, that I've been talking about, and many of the advantages I've been talking about, is Globus Connect. So Globus Connect is a little software agent that is running at each of these storage systems. So in order for Globus to be aware of the storage system and interact with the storage system, that system needs to be connected to some place that's running Globus Connect. Um, that's a simple agent to install, especially if you're installing Globus Connect Personal. So there are two flavors of Globus Connect. There's Globus Connect Personal, and that is really meant for storage that's only being used by one person. Your laptop is a classic example. That would be for whatever, storage on your laptop, or maybe your external hard drive that's connected to your laptop. And then there's Globus Connect Server, and that you'd install in systems that are used by many people. So, classic example is the storage at your research computing center, right? The storage that your university or campus or institution offers to all of its researchers. So it's being used by many people. And generally, that's installed and maintained by whoever's the system admin for of that storage. Okay, so what types of storage exactly can be connected to Globus? A variety of types. I've mentioned most of them, I think, by now. So all of the big commercial cloud players, including Box and Dropbox as well. Out of the box, Globus automatically connects to any or can connect to a POSIX compliant storage system. That's free. The premium storage systems that I've listed here can come with your institution's subscription, and you can use those to connect to institutional types of storage, tape archives, these commercial clouds I mentioned. Also for free is if you want to connect Globus to any of your personal storage. So for example, a laptop running Windows, Linux, or Mac. Okay. So one last slide before I get into the demo, and I just want to say I'm going to be demoing the web app, and I've talked a lot already about the web app, about opening a browser and logging in. But we have a lot of different ways you can access Globus services. You don't have to use the web app. If you are more comfortable on the command line, you can use our command line client to, for example, submit a transfer request. We also have APIs, so all of our services are offered through API. So if you're a developer and you want to integrate these capabilities that we're talking about today into your applications, you can do that using our APIs, and we help you to do that because we offer a Python SDK as well as a JavaScript SDK. There are also a number of ways you can interact with Globus services through automation. And I'm highlighting here our flows service, which allows you to automate sort of an entire data flow. So if you're find yourself moving data and analyzing data and publishing data in the same way over and over again, flows is an excellent way to automate that. And Greg will talk more about that later. But what I'm going to do right now is actually do demo of data transfer. So I will walk through the same steps that I just talked about in that slide. So I'm going to pretend I'm the researcher. Sorry, I'm just checking time. I'm going to pretend I'm the researcher and go through what I went through on the slide. So let me switch to Chrome. Do you see a Google map? If you're
Yes.
Yes,
nodding, I
we
can't
do.
see you. Okay,
Yes.
thank you. All right. Okay, so let's say I'm the researcher and I have received an email from an imaging center that my images are ready and I need to come pick them up and take them out of the center. And I want to move them to my campus computing center where I'm going to analyze them. And so I would log into Globus, as I said. So how am I going to do that? I'm going to go to our website, uh, globus.org, and you can go there and click on the big login button right here. And you'll be taken to our login page. And as I mentioned, you can choose any one of the 2,000 institutions we have listed here. I am at the University of Chicago. I have a University of Chicago identity, so I'm going to log in using my University of Chicago identity. If you can't find your institution listed here, you can also use your GitHub ID, your Google ID, or your ORCID ID to log in. All right, so I am going to log in as the University of Chicago researcher. I'm going to hit continue. I have logged in this morning. Yeah, so um, you didn't see it, but what will happen when you log in for the first time is you will be directed to your organization, and you're all probably familiar with this flow. You are directed to the login page at your institution. You put your credentials in at your institution, not to Globus. Globus never sees your password or your credentials. You log into at your institution, and then you're redirected back to Globus, and that's what just happened in the background here. Um, okay. This is the landing page for our web app, and this is our brand new user dashboard released yesterday. So I'm still getting used to landing here. Um, and this dashboard just gives you an overview of the tasks across the Globus services that are executed and give you some notifications if you have any and announcements. But I'm the researcher. I want to get those images off of the data center. I'm sorry, off of the imaging center and move it to my campus data center. And so in that email, there would be a link that when you click it, you automatically would open the data that's waiting for you at the imaging center. But in my case, I don't have access to that email right now. So I go to the file manager. And this is really where, and the file manager is where you look for the data you want to transfer and submit that data transfer request. So and this panel here, you can imagine is the source, point A. This panel here is going to be the destination. This is where you're going to send the data. So the first thing I need to do is I need to find that data on the imaging center. So I'm going to search for a collection. So a little timeout here on Globus vocabulary. A collection is a Globus word, the Globus word for um, rough approximation, you can think of a collection as a storage system. So a collection can be an S3 bucket, a collection can be a tape archive, a collection, you would have a collection at your campus computing center, you would have a Globus collection perhaps on your laptop. So that you can think of it as the door, the Globus door, the entryway into a storage system that Globus knows about. I say that's a rough approximation. Often a storage system will have multiple collections, so there'll be multiple ways you can access that storage system. But for now, you can think of it as this is just the doorway, the Globus doorway into a particular storage system. So I need to find that collection or that doorway into the imaging center that I use. So I need to search for a collection. And when I search, Globus gives you some tabs here that filter some collections. So it'll give you the recent collections that you've accessed, ones that you can bookmark yourself. Maybe these are ones that you access often. These are collections you own. You've created these collections yourself. And these are collections that someone has shared with you. And so I have Right. A lot of people, sorry, blanked. A lot of people have shared their collections with me. But I want to find my imaging center collection. So I've used it recently, so it's listed here. I could also have just searched for it here and it pops up here in the search results. So I'm going to select that imaging center. And there is my data. This is a directory listing of my data and only my data at the imaging center. And here's the folder that the imaging center uses to drop my images. I can take a look at that folder using Globus. Here's what's in that folder, some old data, and then here is my brand new data waiting for me. And I can take a look and see what's in there. Some metadata. So this is the sample data. And information about how the images were collected. Here are the actual raw images. Um, I can, if I like, I could, depending on the file format and depending on how your browser is configured, I could open these files actually in the browser and take a look at the images before I move them. I don't need to do that today. These look like what I ordered from the imaging center. So I'm going to move this entire folder. I'm going to go back up the directory tree. I'm going to move this folder. I'm going to move it to my campus. And again, I need to find that collection or that doorway into my campus computing center and the storage that I own there on campus. So again, I'm going to search for that. And the name of my research computing center is the Robson cluster. This is our HPC cluster that the researcher has on campus, and I can select that, and it will open to my home directory on campus. So this is my home directory. These are my files at campus, and now I want to move data sitting at the imaging center to campus. And by the way, these files are actually on an S3 bucket. And the data that's listed here is just on some POSIX storage. These two storage systems know nothing about each other. They are not connected in any way. But nonetheless, I can just easily drag and drop data if I want to from this S3 bucket to my campus just by dragging and dropping. And I see that the transfer submit request has been submitted successfully. I could also have used the start button, but um, that's all there's to it. I've just transferred either a few megabytes or hundreds of terabytes just by opening up these two collections, browsing to the data location that I want to move, and selecting the data destination. Um, if I want to monitor the transfer or see how it's doing, I can go to the activity page here, and this lists all the transfers that I've submitted to Globus. Here's the one that I just submitted. It was actually a very small amount of data, so it's done already. But I can look and see some of the metadata about the transfer, some metrics about what happened. I can look at the logs of the transfer. Again, this is a very simple transfer, so not many logs. I can download, I can view and then download all of the files, every single file that was part of that transfer that was moved to the destination. Take a breath. I want to show you one more thing before I go move on. Hang on. And that is when I move that data just now, I just use the default transfer options, but there are a lot of different ways you can configure a transfer, a lot of different options. And I'm going to show you some of those now. So one is you can label the transfer. So you can give your own custom label to the transfer. So move images from XYZ sample to campus, for example. Um, I can either transfer everything or I can just sync. So I can transfer only things that are new, things that aren't already at the destination. And by new, it's up to me how I define new. You can move it if the file size is different, if it doesn't exist at all on the destination, or even if the checksum is different between the files. So I can sync rather than just do a complete transfer. Lots of other options. I'm not going to go through these. I'm going to just highlight a couple. I can encrypt the transfer. I can disable notifications. So Globus will send you an email when the transfer is done. It'll send you an email also if the transfer has failed or become inactive for some reason. You can also schedule the transfer so you can set it up, but it won't start instantly. You can choose what day and time the transfer will start. This is really handy when your campus is throttling network, like our campus is doing at the moment, during the day. Um, if you want to schedule it at night, then when you know you're going to have a lot more bandwidth available to you, for example. You can also set set a transfer to repeat. So this is like setting up a recurring meeting. You can set up a recurring transfer. If you are transferring every week from this imaging center, for example, you can set up a transfer to just automatically kick off every week. So for example, I'm going to set up a transfer. Let's say I want to set up a sync every day between the imaging center and my campus cluster, right, for the next week. I'm going to just say after 7 days. And that way I'll know if they put any new images in that folder for the next week, they'll automatically be moved over to campus. I don't have to check back if anything's new. I don't have to kick off a new transfer if there is something new. It just automatically will be moved over once a day. Um, and to kick off what we call a timer, that's quite easy. I just configured it. You just saw me configure it in the options, and then I just hit start the transfer. And instead of a transfer request, a timer is created. This gives me a warning that says, so my campus has configured this Globus collection, this doorway, to require that I log into campus every 11 days. So they want to make sure I still am at campus and I still have a campus identity. And this just lets me know that every 11 days I'm going to need to log into my campus identity provider. And that's fine. And I accept that, and then a timer should be created, and it's just creating now. There it is. So the timer success request has been submitted. If I want to look at my timer, I want to make sure it's still running, or I want to take a look at what's happening, I can go to this timers page, And this will list all these recurring transfers I've got set up. This is the one I just set up. And this one actually I've paused, but this was a nightly backup to Azure. So timers are also a great use case for those, or some kind of nightly backup or daily backup, periodic backup from one location to maybe a tape archive or maybe some cold storage somewhere. A lot of people use timers for that reason. Okay. Um, I think I'm going to move on to data sharing, unless there are some questions I should answer first.
Thanks, Bridget.
Okay.
Again, please enter questions into the chat or we'll unmute you.
Okay, I'm going to go ahead then. All right. So that's data transfer. Pretty simple. And it should be simple. It's what we try to make it simple. You can also share your data using Globus, and there are a lot of use cases. I'm sure you're aware of at least some of them for sharing data. So you might want to share data, just sort of an ad hoc one-off. You want to share a particular folder or a particular set of data with a collaborator at a different institution. Or maybe you're part of a multi-institutional project, research project, and all of the institutions want to share that data amongst each other. It's another good use case for data sharing with Globus. Or maybe you want to share your data with a whole entire research community. So you want to share data through a data repository, for example, or maybe you even want to just share it publicly. Those are all use cases that can be solved using Globus. Um, okay, so let's walk through sharing. And again, how would you do it and why would you do, what are the advantages of sharing through Globus? So how does it work? So we're back here. We have our researcher and she just transferred data from the imaging center to her campus compute resources. So that transfer is done. So we can just get rid of the imaging center. The data is now sitting on campus. She's done some analysis. There's some interesting results or maybe some confusing results, and she wants her collaborator to take a look at it. So she wants to share that data with her collaborator. She wants to give her collaborator access to that data. So how would she do that using Globus? So again, you would log into Globus. And then using Globus, you'd browse to the folder you want to share. You'd pick that folder, and then you would specify the person that you want to share it with or the group of people that you want to share it with. And that's all that you need to do. You're done. What Globus does is the service stores that what we call a permission. And it overlays that permission on top of the permissions that are already configured on the storage system. So that's an important point. Globus doesn't change those underlying permissions in any way. It doesn't touch the local permissions on the storage system. The sharing permission that Globus stores is just an overlay on top of the already existing local permissions. So it is impossible for a researcher to share data that she herself does not have access to, for example. Okay, so that's all that the researcher needs to do to share data. And notice she didn't need to move the data to a data sharing platform. She didn't need to move that data to, let's say, Box or Google Drive or some place where both she and her collaborator have access. Um, she also didn't need to contact the storage admin and ask for a temporary account for her collaborator, right? She didn't have to move the data anywhere. She could share it in place, and she didn't have to ask anyone for this local or temporary account. So she could share it right away with the person she wanted to share it with. Um, so that's very convenient. And then what does this look like for the collaborator then who comes and wants to access the data that has been shared with them? So they would have received an email from Globus that says, "Hey, Bridget's shared data with you. Here's a link to access the data through Globus." And the researcher could click on the link. They would log into Globus, and then they would use those overlay permissions, allow them, they would then be able to see the data, just the folder that's been shared with them, um, using Globus. They'd be able to see and access that data. And then they could download the data to their laptop, for example, or they could move the data, for example, to their own campus or their lab server or a computing center a national computing center that they want to use and compute over the data. Okay, so that's let's see, make sure that I mentioned everything, no local account, no need to stage the data. You don't, the collaborator doesn't have to have logged into Globus beforehand. You can share with an email address. As long as you know the collaborator's email address, you can share the data. Okay, so let's actually demo. I'm going to demo data sharing and just the way I demo transfer. I'm going to walk through those steps that I just went through on the slides. I'll do the same thing in reality as a demo. Okay, so here we're back in Globus in the web app, just right where we left off. Let's go back to the file manager where we left off. Here's the imaging center. Data, and here is the data we just moved to the cluster. Let's make sure it arrived there. I'm going to refresh this list and I should see, yep, here is our folder with our new data, and there are the images and the metadata. Okay, let's assume that an analysis has been done. I'm going to create a folder, and I can use Globus to create folders, manage my folders, delete them, rename them. I'm going to create an analysis results folder on my campus cluster. There it is. And let's assume there are some analysis results in there, and I want to share those with my collaborator. How do I do that using Globus? Well, I would click the share button. And what I'm going to do here now, this is a one-time step for sharing. You don't need to do this every time you want to share data. You just need to do this once. Um, and that is you create a guest collection. And remember, I said a collection is kind of the Globus entry point into a storage system. Well, a guest collection is the entry point or the doorway for your guests. So this is the special door or the special way that your guests can enter uh, you can access your data, go through that door to access your data. So it's very easy to create a guest collection. You just click the button and give it a name. I'm going to click the button. I'm going to give it a display name that people could recognize, my guests can recognize when they come look for it. I'm going to, so Rauman shared data. If you'll notice, there's a path here. This is we call the root of the collection. So um, anything in this path is not accessible to your guests. Anything below, you can make accessible. It's not accessible now. Just creating a guest collection doesn't give access to anybody. It just creates that doorway. It does not create the guest list. Um, so you can root this collection. You don't have to root it at your home directory, for example. You can root it wherever you want within the directory, within the file system that you have access to. Okay, so this is going to be the name of my guest collection, and all I need to do is create the collection. I'll notice here you can configure this so that you get emailed every time a collaborator accesses the data, if you want to know if they actually came and looked at it, for example. Okay, so I'm going to create the collection. And as I said, I do this once. I don't have to do this again. What I do over and over again is manage that guest list. Who can access the data in this collection? I can access it. This represents me, so that's a given. I can access it. But now I'm going to create some permissions or the guest list. So first of all, I want to share with my collaborator. I don't want to share everything in that folder with my collaborator. I only want to share the analysis results. They don't need to see the raw data or the metadata. So I'm just going to share the analysis results. I'm going to share it with one user, just my collaborator. I'm not going to share it with a group of users right now or everybody who can log into Globus or even publicly. So I need to tell Globus who the user is I want to share with. My collaborator's name. Uh, Looks like my collaborator has already logged into Globus once, at least once before. But even if they hadn't, that would have been no problem. I would have just put their email in, and that's all I would need to do. So I'm going to um, share with this collaborator. An email will be sent to them automatically saying, hey, your data's, Bridget's shared some data with you, come get it. I could give my collaborator write permission, but I'm not going to do that because there's no reason for my collaborator to be able to write to my campus storage. I only want them to be able to read the folders. I could give them write if there was some reason maybe we want to exchange data. Maybe he has some results he wants to give me. I could give him write permission, but I don't need to, so I won't. I'm going to add that permission, and that's all there's to it. I've added that permission. I've shared the data. I could add more permissions. I'm going to add one more. In this case, I'm going to share this with a group of people, and I'm going to share it with all of my lab members, for example. And since it's my lab members, I'm going to share everything, all of these, all three of these folders, not just the analysis results. So I'm going to share all three of these folders. And as I said, let's share it with a group of people. And so then I select a group here. I'm going to search for my group, which is my Raman Lab current members. So this is just a group of everybody who's currently in my lab. So I don't need to go and enumerate each person in order to share with my lab members. I can just share it with the entire group and I add the permission and I'm done. So I've shared. You'll notice now here, this lists my guest list. Um, you can see I shared the root of the guest collection with my lab members, but I've only shared the analysis results, this path, with my collaborator. Okay, just need to pause for a drink. Um, Last thing I want to show you as the data owner, right? So now I'm still the researcher. I'm still the data owner. I am a busy PI and I don't want to always have to create a sharing permission for every collaborator that asks me to share data. I want to delegate that privilege to my lab managers. And so I can do that easily in Globus. I can create a role for them. So here are the roles tab. I have roles. I'm the owner and the administrator, but I can also assign a new role called Access Manager. The access manager is a person who can manage that guest list. That's all they can do, but they can manage who can access what. So I am going to, in this case, I'm going to assign an entire group. I'm going to assign my group of lab managers. I trust them to know uh, with whom to share the data, and I will just add that role. And now when they log into Globus, they're going to see this guest collection and they're going to be able to go and add those permissions that I just showed you. Okay, so that's what it looks like if you're sharing data. Now let's take on the persona of the collaborator and see what the user experience is when you, as a collaborator, come to Globus and want to access that shared data. So I'm going to log out and then log back in as the collaborator. So I'm going to log back in. And in this case, I shared with my collaborators Google account, so I'm going to log in through Google. I'm the collaborator now. I'm going to pick, this is my Google account that was shared with. And again, I would have received an email that has a link directly to Globus. But let's say I don't have access to that email. I'm just a collaborator. I open up Globus and I want to find that data that's been shared with me. Again, here's the dashboard. And I go to the file manager because I'm looking for these files, right, that have been shared for me. So I need to go to the file manager and search for a collection. What is that? Where is that guest collection that I have access to? I haven't used Globus in a while. I don't have anything, any recent collections. I've bookmarked one single collection, but that's not the one that's shared with me. I don't have any collections myself. I've never created any. But when I go to share with you, I see the collection that was shared with me. Okay, so here's the realm and shared data. So all I need to do is click on that and it will show me the files, the directories that have been shared with me. Notice, like we know that there are other folders here in this directory, but as the collaborator, I only see the analysis results folder. I have no indication that there's any other data here. So I just see the analysis results. Great. So I could download some of the files in here if I wanted to, and that's just a simple browser mediated, a browser-based download. Fine for few small files, but I don't want to do that for really large amounts of data. Let's say this is a 200 gigabytes or a terabyte or even more. I don't using a browser download is not it's not reliable. So I want to use Globus. I want to have Globus manage that transfer, but I want to transfer it to my laptop. That's where I want it. I have some applications, or maybe I have my own algorithm I'm developing that I want to run over the results it's running on my laptop. And so how could I do that so that Globus manages that transfer? So remember, I said the secret to having a storage system be aware of Globus services is Globus Connect. So what I need to do is install Globus Connect Personal on my laptop, and it's really easy. Um, I click search, and you may have noticed here that there's a link here to get Globus Connect Personal. And so I click on that, and then I can download it. And this whole process of installation will be familiar to you. It's just like downloading any other app from the internet. I could download it for other operating systems if I wanted, but I'm running a Mac, so I'm going to download it for my Mac. You can see in my browser it was downloaded. You can see I've downloaded it a few times. I'm going to open it up. And here is what opens. This should be, again, if you're a Mac user, super familiar. If you're a Windows user, it will be just the typical Windows installation as well. Same for Linux. So I'm going to drag and drop to the applications folder and then open up the application. And yes, I trust Globus. And the application's opening up. And the first time you open it up, you're going to need to log in. Globus needs to know who you are. So I'm going to log in and I'm going to consent. And that's it. The login was successful. I had already logged in. Globus already knew who I was. So I didn't have to log in again. Let's go back here. See, it knows now that I was logged in as dormouse@gmail.com. The only other thing I need to do is give this collection a name. So what's the name of, again, the door to my laptop. And this, by the way, is only accessible to you. This is a private collection. No one else sees that collection or can access it unless you want to change that. But by default, it's private. So I'm going to just give it a name that I will recognize. Let's call it Midnight MacBook. Um, and then I hit save, and that's all there's to it. And now I'm done. I can exit setup. And now when I go back to Globus and I go to the file manager and I'm going to search for my collections. I now see that I own a collection. Here is my laptop. It's connected to Globus. Globus is aware of it. As long as I'm running Globus Connect Personal, you can connect to the Globus services. I click on that, and you'll see this is the laptop that I'm running right here. Um, Again, it illustrates that if you view some storage through Globus, it's going to look the same, whether it is on a MacBook or in some high performance POSIX compliant storage or in Google Drive or S3, it all looks the same and you interact with it in the same way. So this would be then, if I were the collaborator, again, as simple as I'm going to drag and drop over there, and now the analysis results should be transferred to my laptop. I'm going to refresh the list, and there they are. And just to drive the point home, let's actually look at this through the lens of my laptop. And if I go to my home directory, which is where I transfer it, there it is. Oops, there are the analysis results. Okay, I'm going to mention one more thing, two more things actually. One more thing I want to mention is some of you might have noticed that when I was searching through these collections, I had bookmarked this Access resource. And I can open that Access resource up. And this is my directory on Anvil. And how am I able to do that if I am dormouse240 at gmail.com, which Access does not know about, does not recognize? Um, the way that happens is Globus has a concept of linking your identities because you do not have just one identity. Your campus identity doesn't give you access to all of the different places you have your data. You might have an Access identity, you have a Google identity somewhere, perhaps you have an identity at a national supercomputing center. You might have an identity at a university that you're transitioning from, right? You might have two university identities. So in Globus, you are represented as a set of different identities. So you can link all of those together. So if you look in settings, this is my identity set. I have two identities, and that means Globus recognizes me both as B. Rauman at access-ci.org and as dormouse at gmail.com. So and that's how, in the file manager, I can easily move data across these authorization boundaries. I can drag and drop data or, select how many files I want to move and hit start from Access to my laptop, even though those two storage systems know me as completely different users. Okay, I have 4 minutes, which is really good because I only have one more slide. Um, I've already mentioned the core security features, so I'm not going to go over those again. The one thing I wanted to remember to say is that um, if you have particularly sensitive data or data with regulatory requirements that you have to comply with, Globus offers features that allow you to securely move your data and to comply with regulations. And so, for example, if you are moving PHI, you can use Globus moving PHI if your organization authorizes you to do that and has a subscription with us. So keep in mind that Globus is a good way for you to manage your sensitive data as well as your open research data. I'm going to pause there for questions and the opportunity also for Greg to present. Any questions for me before Greg takes over?
This is Jeff from Notre Dame. Just want to make sure that I understand. So let's say I want to share data out of a Google Shared Drive that has restrictions on it. Globus will not ignore those restrictions. Is that correct?
Absolutely right. That's right.
That's all I needed to know. Thank you.
Yeah, sure. Okay, Greg. Uh, there we go.
Great. Thanks, Bridget. I hope everybody can see my slides here. Yeah, so thank you very much for that. And, as you've seen, thus far, we've talked about transfer and sharing, and really good reason for that. That's our bread and butter. And as you can see, we've transferred 3.8 exabytes of data. I just downloaded that. Or I just snapped that from our website. So hopefully by GlobusWorld in person, we'll have that up to 4 exabytes. So yeah, I'm going to talk about some of the other features that we've got in Globus and really concentrate on some of the automation services. But first, I'm going to talk about the latest toy in the box, and that's Globus Streaming. And, like I said, we've talked about transferring files, but what happens when you can't wait for that file transfer? You can't wait for that file to be transferred. You need direct memory to memory access. And this example that we've got here, there's a radio telescope that's streaming data up to a compute facility that's doing some analysis to help steer the telescope. But I actually just learned about another use case this morning called base calling, where a sequencer is doing a similar thing. It's streaming data up to a high performance computing center where there's a neural network running some analysis, and it's telling the sequencer, where to look further. So there's actual other use cases. And really, I mean, it's just a way to set up a nice secure FTP based or grid FTP based secure tunnel, just like other methods of setting up tunneling. But you get all the grid FTP goodness with it. You get the security, you get the speed, you get the reliability of the transfer, and the simplicity of everything set up with grid FTP implemented through Globus Connect server. So if you come to GlobusWorld in person, we'll talk a lot more about Globus streaming. Okay, so moving on to automation. And when we talk about automation, we used to talk a lot about the kind of the publication side of it, and then we kind of shifted to the data inception, all the instrumentation use cases. And it's really not any single use case, but I find that these kind of bookend that end-to-end curation story, and that's really kind of what automation is. It's an end-to-end use data curation use case. And so what's the holy grail? It's being able to build automations with a nice managed service. So you get managed reliable task orchestration, right? You don't want to host it. You want somebody else hosting it. This is the days of SaaS. You want it to span all the resources that you use in your day-to-day research data management tasks. You want a nice event-driven execution model, a state machine. There's a reason that state machines are used in industrial automation, and probably a reason why many of us learned to program with state machines. With a nice declarative language, something that you can really define those steps that you want to execute, and as well as a definable input schema. You want to be able to run those automations differently from different times. So when you initiate an automation, you want to be able to put in some parameters. You want it to be reusable and shareable. If I'm a lab manager, I want to create a flow that I want all the people in the lab to run with their own input schema parameters. So you want it shareable, and it's certainly extensible, right? You want it so you can build upon it. So enter Globus flows. Globus flows and a flow, it's just a sequence of steps. It's based on AWS step functions, and we call those steps actions. And you can see at the bottom of the slide there, these are a sequence of steps that you might do in a typical automation where you transfer, maybe do some compute tests on that, transfer back to another store, maybe some human interaction. So just a bunch of steps that you need to do in your research data management tasks. And not only can it be linear, but you could have choices in there where maybe an action drives a choice, and based on that choice or what happened in the previous action, it drives completely different set of actions. So, it's a step function based, but certainly something that you can do kind of in a flow. It's hosted by us, hosted by Globus. Which is just yet another service that we have. It supports all those Globus resources that you might be using. So you see down below, like transfer, it supports your endpoints. It supports your collections. You'll see there's compute. You're going to learn about that this afternoon. I'll touch upon it as I go on. But just kind of all those general Globus resources and those resources you use in data management. It's very flexible, right? It's you create a flow definition. It's JSON, a bunch of JSON that you put together. You create your own input schema, again in JSON. And it's extensible via custom actions. So if there's actions that you want to do, or a certain way that you want to do things, or maybe there's an instrument you need to trigger, you can do that by custom actions. And it's shareable. Right? It's hosted by Globus. It's in our Globus services, and you can share it out just like Bridget showed how you can grant roles on collections. You can grant roles on flows as well, so others can run them, others can manage them. Okay, so talking a little bit about the flow life cycle. I talked about the flow definition in the input schema, which is just a bunch of JSON. Yeah, maybe scary JSON at first, but one of the great things is, there's no original coding done, right? You can go and look at previous flows, get ideas from there, integrate that into your flow. So there's lots of examples out there. We also have an IDE. So a graphical IDE where you can kind of visualize the flow. It's really handy, especially after you've done a bunch of JSON, just to make sure that everything's connected in the way that you think it should be. So you create your flow definition, you create your input schema, and then you deploy that to the flow service. Lots of different ways to do that. You can do that in the web app. You can do that through the SDK. You can do that through the CLI. So lots of different ways to interact that. But you deploy it to the flow service. So now it's in the library. And initially, it'd be something that only you would want to look at because you're going to want to run that flow and make sure it works in the way that you think. So you're going to run it, you're going to debug it, you're going to monitor that flow, make sure it works in the way that you think it should. And then after that, you're going to set that access policy for visibility and for so others can execute those flows in the flow library. So you make it available to others. You can make it available to select group of individuals. You can make it available to everybody in Globus. So lots of different ways to control that. Okay, and then the whole point is, right, you write this once, you run it many times. It's for those repeatable tasks. It's for those things that you need to do over and over. Yeah, so that's Globus flows in a nutshell, the life cycle in a nutshell. Okay, so how do you use a flow? What happens when you run a flow? What's going on? So each time a flow is started, it's called a run. You'll hear that terminology used. I'll use that terminology. It's called a run. And you can start those runs from the web app. You can even initiate a flow from a timer. So if you want that flow to start in the future, or you want that flow to occur over and over, you can see just how Bridget showed you timers for file transfers, works with flows as well. Again, the CLI, our APIs and our SDKs all wrap our services, including flows, so you can initiate the flows that way as well. We do have some trigger examples. So let's say you want to initiate a flow based on something that's happened in an instrument. We've got some examples to help you do that as well. Okay, then you're going to provide input to that flow. It's going to run that input schema, right? It's going to say, okay, here's some parameters I need to run this flow properly. And you're going to input those. And then it's going to perform a series of actions with that input, right? It's going to go through these actions and run those in that sequence that you've defined in the flow definition. And then you can manage that run. You can monitor. You can monitor that run, see what's going on. You can even grant roles on the run. So if you've got a run that's going to take days or weeks or months, and you're going on vacation, you can grant a role on that run to one of your colleagues so they can monitor it, make sure things are happening, and you can give them the ability to kill that run. So if something goes out of control, they can stop it as well. So just like you can give roles on transfers or roles on endpoints, roles on collections, roles on flows, you can give roles on the actual flow run as well. Okay, there are some Globus provided flows out there. As I mentioned, there's a lot of examples. We've got some in our Git, but we also have some that are pre-deployed in the library. There's a two-stage Globus transfer, which I'm actually going to demo, where you transfer data from one collection to another, and then to a third collection and delete it off that middle collection. There's transfer and set permissions. This is a classic one, right? Transfer it up to a data store and then share it out with a select set of individuals. That's a really cool example. And then move, copy and delete files as well. So it's kind of a subset of that first transfer. So there's Globus provided flows that you can look at. And when I show you, you can actually see the flow definition and the input schema definition as well. So you can, steal those examples. Okay, so the flow that I am going to show you is a very simple data staging use case. We're going to transfer files from from one store to an intermediate storage, and then we're going to transfer it up to that end storage, where their final destination, and then we're going to delete it off that mid storage. And I'll show you how that flow works. Okay, so let's go ahead and demo that. I am going to let's see, bring that down. Let's slide in the web browser, and then I'm actually going to slide in my laptop. This is my Globus Connect personal collection. This is the directory that it looks at, so you can see it. It appears there because we're going to transfer from one Globus Connect Globus Tutorial Collection 1, and this is a collection that's available for you to use. It's a nice demo collection in the Home Share Go data directory. There's 3 small text files, and then Globus Tutorial Collection 2. We're going to use that as the destination collection. So again, these are available for you to use. You can run this example. If you were following along with Bridget, you created your own Globus Connect Personal, so you've got that as well. So let's go ahead and go to flows here in the left-hand menu. I'm going to click on flows and go to the flow library, and I'm going to click on Globus provided flows. So here's the Globus provided flows. And let's just go ahead and we're going to look at this 2-stage Globus transfer. I'm going to click on that, and we can look at the flow definition, right? So here's all that scary JSON that makes up this flow. But again, if you take a look at this and follow along, doesn't become so scary. And likewise, we can see the not just the definition, but the JSON that makes up the input schema, right? Things like it's going to want that initial collection, it's going to want that intermediate collection, it's going to want to know the end collection, and some other parameters that we'll see as we go ahead and we run that flow. Okay, so here we go. We got that 2-stage Globus transfer. I am going to go ahead and start it. And here it goes. It's going to ask for that input schema. These are things that are needed to run the flow. So I am going to start with that Globus Tutorial Collection 1. And I'm going to browse to the Share Go data directory. And there's those 3 small text files that we hope to transfer with this flow. We're going to get an intermediate collection here. And we're going to use Greg's MacBook. You can't use this, but you can use, because this is a private collection. This is my Globus Connect personal collection, but you could use your Globus Connect personal collection of your own, and in that Globus endpoint directory. And that's what we're going to see here. So we're going to see those files pop in here and then get deleted. And a destination collection. We're going to go tutorial collection 2. So that's our destination, and we're just going to put it in that root directory. That little hash is going to look different for you, but that's the root directory. So we can give it some optional parameters here. We can actually label different parts of this flow. That first transfer, we can give it a separate task label, so we could see that in the task monitor. The second transfer, again, we could all label these uniquely, as Bridget showed when she did a transfer. We're going to keep that checksum verification to true. We can add tags to this run, so it's searchable and findable by others if that's the case. But in this case, we're not going to need that. So I'm going to call this Greg's GW 2026 flow. Okay, so I've got that flow all named, this run. I've labeled the run. I could start it with a timer if I want it to occur in the future, or if this is a flow I want to occur over and over. But I'm just going to go ahead and initiate that. So I'm going to go ahead and start the run. So there we go. We're off and running. If I go back to the flows library and I click on runs, we see that flow, that name flow that I just started here. And we click in there. You can see the flow is now put stuff from Globus Tutorial Collection 1 up to my personal collection. I can dive into the end of the event log so I can see what's going on with the flow. Here's where I can provide roles to it. So if this is a long running flow and I want somebody to take over, I can give somebody else a role so they can monitor this flow. You can stop it. You see that it's already deleted those files, and that's the last step. So if I go to the overview in the event log here, I should see that the flow indeed succeeded. And if we go back to the file manager in Globus Tutorial Collection 2, and I refresh, there we go. Those 3 files were transferred on. So there's a really simple example of a Globus flow, and an example that you can run yourself and that we have in our flows library as Globus provided flows. Okay, so let's go back to the slides and bring it home. Oops, there we go. Okay, so we saw this simple data staging use case as a Globus flow. So I mentioned Globus Compute, and I'm not going to dig in too much here because I'd be spoiling the next presentation. But Globus flows, or Globus Compute, what is it? And you saw in some example flows where a compute step could be put in, and it's really kind of a key component to Globus flows. And it's a managed federated function as a service for reliably, scalably, and securely executing functions on remote endpoints. Doesn't matter what that thing is, whether it's a supercomputer or your laptop or a Raspberry Pi. Lots of different ways to kind of distribute that task. And nutshell, Globus Compute, it abstracts the complexities of HPC and distributed computing by exposing a Python function that run on compute agents that are managed by the Globus service. And really, this replicates this proven data management approach, right? It's effectively fire and forget computing, right? You don't care where that task is running. Globus is doing that management. And that's just like our fire and forget file transfer. As I mentioned, you don't care where that's running, what kind of job or what kind of hardware it's running on. Just like we abstract storage, we abstract that hardware just as a Globus compute agent, so that function is running on an agent. And then, of course, as you've seen with all our services, it's secured by Globus Auth. So you've got that federated access control securing the whole thing. Okay, to the last thing I'm going to mention about Globus Compute, there's 2 flavors of Globus Compute. There's the single user, and think think Globus Connect Personal, right? There's the analogy there where it's installing and you're installing it on a local machine. And then there's the multi-user Globus Compute where your administrator is installing it up on a HPC system. So you could do perhaps more intensive calculations there. And Lev and Vas are going to go into this in much more depth in the subsequent session. Okay, the last thing I'll talk about here is Globus Search. And Globus, we operate a metadata store that you can reference your data in. And it's schema agnostic, so it's a non-domain specific data store. There's fine-grained access controls to that metadata. So different components of that metadata you can control. There's going to be different access layers there, and so it can be accessed by different individuals, different identities, or different groups of identities. And of course, it's secured by Globus Auth, right? So it's got that whole federated identity service underneath it as a foundation. There's extensive query and discovery APIs, so very simple APIs for simple data search, as well as very complex faceted search as well. So, and you would use those to create data portals. So if you're creating your Globus powered data portals, you can use the simple and complex search to actually search for your data and then initiate a transfer. So you can facet down to that data that you want to find, and then this is the data set I'm interested in. You can pop a Globus transfer window and then transfer that data to a collection of your own. And actually, since we've got a little time, I'm going to slide in this example, and you'll see that I referred to that here. We've got a really good example of a Globus powered data portal. This is the Advanced Leadership Computing Facility at Argonne and the Community Data Co-op. This is something you can access. Now you can't access these data sets unless you have the correct permissions. But you'll notice that the material data facility here is public data. So if you can go down and search that project, and you can say, well, gee, I'm interested in microscopy data. So I'm going to select that. You can see the search results facet down to those 79 microscopy data sets. And I'm only interested in those data sets that were done way back in 2016. And so there we go. It's facets down to that those 8 data sets. And I'm only interested in those ChIMAD data sets. And now it's faceted down to those 2 data sets. So it's using Globus search and the Globus search index to find these data sets, and they're referenced to a Globus collection. So let's say this is the data set that I'm interested in. If I click on that, it takes me out here to the transfer window, and here's those data sets. I could put in a collection of my own, perhaps my Globus Connect personal collection, and just initiate the transfer and transfer those data sets. So a really slick way to search for data, really slick way then to initiate a Globus transfer. Okay, yeah, so the last thing I'll talk about here is the Globus platform, all the kind of underlying tools and things in our toolbox that allow you to do these neat things that I just talked about. If you are interested in creating your own data portal, we've got a Django portal framework that you can use. We've even got a serverless portal that uses Git as the data store. It's really slick, really easy to create your own very basic data portals. As I've mentioned, as I keep going on, and we wrap everything with those APIs for all our services are available and usable, and we wrap those with a really slick Python SDK and a really slick JavaScript SDK. So lots of different ways to kind of call those APIs and do things in your own applications in a Globusy way. The last thing I'll mention, and I'd be remiss, Bridget talked about the command line interface. If you're interested in, if you like using Globus on the command line as opposed to the web app, that's great. But it's also an excellent mechanism. If you're a shell scripter like me, it's a great way to shell script your automations. So you can do automations with the Globus command line interface through shell scripts, and it's really slick. The other thing is the command line interface. It's kind of a thin wrapper to the SDK as well. So as you're coding in the SDK, if you want to think how the various functions and methods work, the command line interface is a great way to reference that. So putting this all together, right? You can see this now in a common data workflow. This is a microscopy workflow. It could be a sequencing workflow. But you can see we have all the tools there, so you can automate these very complex workflows where you're getting data off that instrument. Bridget talked about, in her example, getting that data off that sequencer very quickly so the next person in line can use it. So you might want to move that up to a compute facility where you're going to launch a job on that and do some analysis on that data. You're going to take those results and you're going to move them up to a data store so others can access, and you may set the access controls on it for who you want to access that data. Maybe put another compute step in there so you can extract some metadata and then ingest that into the Globus search. And you can do that, so some data everybody can see, some data only a select set of people can see. So you can set permissions on that metadata, and then maybe a cleanup step in there to get it off the instrument so the next person in line can use that instrument. And now, fair data by default, right? In your data portals that you may have created with our Globus tools, you've got findable, accessible, interoperable, and reusable data. So a great way to manage your data tasks and really fit to those data sharing and data reuse, data sharing plans that you see in a lot of grants. Okay, the last thing I'll say here before we go to a few minutes of questions. Globus, our Globus docs site, docs.globus.org. Great place to start. There's a ton of information there. Great place to see, to learn more about Globus. We've got a YouTube channel. Globus Online is the name of it. We were called Globus Online way back in the day, and you know how things, you can't change anything in YouTube. So Globus Online is our YouTube channel. Lots of good videos there. I suspect the video, what you're seeing right now, will be eventually be a video up there as well. We've got our help desk, support at globus.org. I can't say enough about them. They are excellent, as anybody that's used Globus and referenced support and asked for some help knows. There's mailing lists out there. So if you want to ask other Globus users questions or, hey, how did you do this? Our mailing list, excellent place to start. And then, of course, the customer engagement team. This is what you're seeing right now. These are people like myself, Bridget, Vass, Lev. We do things, we do these types of presentations. We do office hours. So go to globus.org and kind of look at our events list, and you're going to see office hours if you're interested in coming back and asking specific questions of those of us. We hold those from time to time. And then there's our professional services team. Again, if you're interested in creating your own data portals and you don't have the skill set, but you've got some money, our professional services team is more than willing to help you out in creating those portals. Okay, that's my last slide. I haven't been looking at chat. I'm going to assume that those have been answered, but feel free to unmute and ask other questions.
I think we're up to date with chat, Greg, but anyone have additional questions before we go on break here? Will there be a session on Globus Compute? Yes, absolutely. That's what is to follow. We're going to have a half an hour break, and then we're going to get into Globus Connect and Globus Compute. All right. Well, we will
Okay.
take a an hour break, and please join us again at the top of the hour. Thanks, everyone. All right. Well, welcome back, everyone. Now we will have part 2 of today's webinar, and we'll be covering both Globus Connect and Globus Compute. So let's get started.
Great, thanks, Susan. Hi, everybody. I'm Vas Vasiliadis, and Levy's joining me for this session. We're going to split this down the middle, roughly. I might run a little longer than he will, but I'm going to be talking about Globus Connect, which is the software you use on the data management side of Globus, and then he will cover, Lev will cover Globus Compute for remote computation. So I just wanted to sort of level set. Maybe some people joined after they weren't in the session this morning. So just wanted to lay out sort of the high level picture of how Globus interacts with your resources. So you may have different types of resources on campus, both storage and compute resources. Those are accessible to Globus only when you install one of these two pieces of software here that I'm showing on the left, the Globus Connect or Globus Compute. And then of course that then makes them accessible or visible to our multi-tenant cloud hosted service, and all of this stuff gets wrapped by the security fabric, which is Globus Auth, which you saw Bridget and Greg interact with throughout the earlier session. So what I'm going to cover is a little bit of definitional stuff up front, and then I'm going to walk through installing and configuring Globus Connect server, and I will touch on some of the more advanced topics. In fact, I'll probably just mention them, but I'm not going to spend a lot of time on that because this session, as much as anything, is intended for those who are going to attend GlobusWorld. So we're hoping you will be joining us. And there we will have a much deeper dive. In fact, it's probably half a day's worth of real sort of hands-on tutorial diving into a lot of the details of how you configure and deploy this thing at scale. Okay, so let's jump right in here. So we're talking about Globus Connect. So what is it? Okay, so in a nutshell, it's the software you deploy on your server. Server can be a VM or a physical machine, and it's Linux-based, so we don't support Windows servers, but any of many Linux distributions that we support. So you install that. Typically, it's installed by a system administrator, and it makes the storage sort of accessible via Globus. Uh, it enables the file transfer, the sharing, HTTP access, and a number of other things. And it also really acts as the conduit to your storage for other Globus services. So you saw a simple example of a Globus flow this morning. When that flow is running, it accesses and uses Globus Connect Server to access storage systems for moving data and setting permissions and so on. That's the link to the documentation. Anywhere on the docs.globus.org site, if you just search for Globus Connect Server, that should pop up. There's tons of great documentation on there. So first, just definitionally, I'm going to be using a bunch of perhaps new words and some words that might be overloaded, but I just want to describe them and what they mean in the context of Globus Connect Server. So the first thing we're going to talk about is an endpoint. And this is really just a logical thing that says to Globus, hey, here is an instance of this software that you can talk to. That's effectively how you can think about it. An endpoint, one endpoint maps to a Globus Connect Server deployment. And the endpoint is managed in a number of ways. I'm going to be focusing mostly on managing the endpoint via a command line interface that gets installed, but you can also do some of the things that I'm going to be doing via the web console or the web app. An endpoint can have multiple data transfer nodes, so that's the next thing I'm going to talk about. And it's usually not something that the end user sees. So again, this is very much within the purview of the administrator, and users will access data via that, but it's kind of abstracted and hidden from them as far as what's under the covers. So an endpoint can have one or more data transfer nodes, and that's essentially a server or VM that's running the Globus Connect Server software. The data transfer node, very importantly, must have network access to the Globus control channel. So it must be able to be seen by the Globus server, so it needs a publicly routable IP address. And it's the thing that actually does the data movement. So that's the actual software that runs on their grid FTP, etc., and Apache service for HTTPS access and so on. You can have, as I said, multiple DTNs, and we recommend that you do that. Partly it does improve performance when you've got lots of concurrent users and things like that, but it also provides resilience if something fails or if you need to migrate or upgrade servers or hardware. You can always have your endpoint up and running if you have multiple DTNs. The third thing I'm going to talk about is a thing called a connector. This is simply a software package that implements an interface so that Globus can access different types of storage systems. So by default, we will be talking about POSIX connector. So the POSIX connector, if you will, is sort of built in. And anytime you install Globus Connect Server, that's available to you. We also have connectors for many other types of storage systems that you saw earlier. Those require a Globus subscription. So I won't go into those, but the process is roughly the same. You set up an endpoint, and then by virtue of installing instances of these connectors, you can access one or more storage systems through that endpoint. And so we don't really directly interact with connectors. We actually talk to them, if you will, through this thing we call a storage gateway. So when you create a storage gateway, it uses the associated connector package to deploy some things and configure some things so that you can access the storage system. And the important phrase here is using specified policies. So the storage gateway is one of, and probably the first layer of policy implementation that you have at your disposal as a system administrator. So some of the things that are defined in these policies are which domains are allowed for authentication. So when a user shows up, what credentials can they use to access data on that system? It can optionally restrict what parts of the file system are accessible via Globus. And it can also say that, when someone authenticates and uses the system, they have to re-authenticate every in hours or minutes or what have you. And also for additional compliance, you may want to ensure that someone has logged in with multi-factor, so that can also be enforced. And as I mentioned earlier, you can have multiple gateways on the same endpoint. Typically, we see that for installations where you've got different types of storage systems, but you want to manage them all under one endpoint, so you'll have a different gateway for each storage system. But you can also have multiple storage gateways to the same storage system, but they implement different sets of policies for whatever requirements you have on campus. Perhaps some are one storage gateway is for internal use, the other one is more for collaborators, and so on. And then the next thing I'm going to talk about is, and you've heard the word collection used, so this is just this thing that the user really sees to access the data via Globus. It's nothing that you install, you create one of these. It's just a logical construct once again. And the way I like to think of this is it's sort of a projection of the storage system into Globus, or some part of the storage system, again, depending on whether you've set constraints on that view or not. And this is what the users will see in the file manager. You saw that as part of the demonstrations this morning. And as was mentioned, so we've got these mapped collections where the user must have a local OS account on that storage system. So in this case, the user authenticates with their institutional credentials, and Globus does this mapping between the authenticated identity in Globus to that local POSIX account. And then when the user accesses data, they access it using their local account with their local account permissions. And there was some discussion in the chat about that earlier as well. The other type of collection that Bridget mentioned and Greg also talked about is guest collections, where the user does not require local OS accounts. So this is really intended for collaboration, mostly with external users and institutions, but we see this used extensively within the institution in automation scenarios. There was a question in the chat about, hey, how do I run timers without having to re-authenticate? So guest collections is our answer to a lot of things, as you may have already realized. And so guest collection must be created by a local user, someone who actually has a local account on that system, and it gets sort of created from their mapped collection, sits, if you will, on top of the mapped collection. You can only create these guest collections if the administrator has enabled creation on the storage gateway that is being used to access the storage system. And then I think this was also mentioned by Bridget. So when a guest user accesses data, they can only access data that the creator has permissions to, no more than that, but those can even be further limited, but you can't sort of grant more access than the creator has, the original creator of that guest collection has to the data. And then when you see the data being accessed, it's actually via the creator's local account. So, and I'll talk a little bit more about that later on. Okay, so this is in picture form what I've just described. You have these data transfer nodes, physical or virtual machines, with these connectors, and the endpoint is the logical thing that sort of ties them together. And then we have one or more of these storage gateways that allow you to access the different storage systems under different policy configurations. And then sitting on top of that, sort of above the dotted line, is the stuff that the users see, which are these mapped and guest collections. So two views, I guess I kind of said this, I won't belabor the point, but it's mostly here for you to look at afterwards. So the admin sees all these things I've been talking about, endpoints, policies, access controls, local accounts, etc. The user really just sees collections and by extension their data through those mapped collections, also data that's been shared with them through guest collections. And then they obviously have transfers and so on that Bridget showed in the beginning of the session. Okay, so let's go down a level here and see what actually gets deployed when you install Globus Connect Server. So I'm showing a transfer node on the left here, and you see the three sort of broad classes of packages that get deployed. The main one, the thing that moves the data is the grid FTP server, this thing on the left. The GCS, Globus Connect Server Manager, is the thing that allows Globus, the Globus hosted service that's shown on the right here, to communicate and control that endpoint and that data transfer node and everything that sort of sits on top of that. And then also sitting on the data transfer node is this command line interface that allows us as system administrators to create and update and modify things and manage that Globus Connect server installation. So before we jump into installing the thing, I just want to talk about just some best practices for deployment. So this is a picture we've borrowed extensively from the good folks at the Energy Services Network, ESNet, out of Berkeley Lab. So if you haven't heard of the concept of a science DMZ, I encourage you to go read up more about it. I've got a link here in the bottom of the slides. The idea here is that your data transfer nodes should ideally not sit behind the enterprise firewall, because that really does nothing good for performance. And importantly, you can actually have a very secure setup with data transfer nodes sitting in a DMZ if they are properly configured. And the net result of doing this is that the data, this sort of green line at the top here, flow directly between the endpoints without going through packet inspection and so on. And that's really where you start seeing some of the amazing performance that Globus can deliver. So setting this up on the network, one of the things that some folks will run up against is network access. Depending on how locked down your organization is, you may need to talk to folks to have some ports available. The Globus service uses port 443 to communicate with endpoints and do all sorts of things. So really ideally what we want you to do is have that port accept inbound and outbound traffic from everywhere. You can restrict that, but it severely limits functionality. I think one of my colleagues can, if someone is interested in that, we can post a link as to just how much that, what those limits look like. But we do encourage you to not restrict traffic on 443. The data actually move along or using one of these ports in the 50 to 51,000 range. Again, you could configure these, but this one I will advise even more strongly against it, because almost every other server out there, Globus Connect server, uses the defaults. And so if the other side doesn't know what ports you're using, if you're using a different port range, you're going to have a hard time communicating. So what you want to do is make sure that your host is publicly routable, so you can dig it and see. And a minor thing, but it does sometimes trip people up, is making sure that you have your time server synced so that you're not too far off our time service, because that does have implications on control. And by the way, I'm not looking at the chat. I assume Greg, Bridget, Lev, and others are addressing questions that have come up. But by all means, if you would like to interrupt me and ask a question live, just do so. So let me pause here for a second and see if there are any questions so far. Or if anybody wants to ask a question live. And maybe for those monitoring the chat, if there's something you think I should address now, let me know. Okay, I'll take that as a no. So some of the things additional things you need to think about beyond just, the network config and so on, are what identity provider will you be using, or perhaps multiple identity providers will your users use to access the data. This typically is your campus identity provider, but there's many situations where folks have different identity providers on campus, so you might want to restrict that in some way. Making perhaps some decisions on how you're going to structure these storage gateways. Are you going to have one storage gateway for each system? Or are you going to have multiple, depending on different policies and so on? You may want to think about data restrictions. So by default, the things I'm going to show you today will grant a user access to all the data that they normally have access to through other means on your storage system. But in some cases, it might make sense to further restrict that based on the use case. How long can users, how long is the duration of their sort of authentication? The default when we set these endpoints up is 11 days, but you can lock that down. And in some scenarios, especially if you're implementing secure enclaves and have sessions in place, you typically would want that to be a much shorter duration, so you're forcing re-authentication more often. And then there was a brief mention about compliance. So there are some configuration options, particularly under our high assurance subscription level, that you can set to help you comply with access to sensitive or regulated data. Okay, so all that said, let's actually talk about how we install and configure Globus Connect server. So what I'm going to talk about here are, I've got 7, actually, I think maybe 8 things lined up, but the ones that are highlighted in white here are the things that you can do without a subscription. So anybody that is involved in nonprofit research can create and install Globus Connect server, create an endpoint, and access their data for transfer without really requiring a subscription or doing anything special. I think Bridget talked to our freemium model earlier, so I'm not going to cover that again here. But that's that. I'm going to focus on that first, and then depending on how much time we have, I'll go into a few of the subscription-related features. Okay, so first thing we do when we install is install the packages. So we have, as I said, repositories for and packages for most of the common Linux distributions. So you run a series of commands and you get the packages onto your system. And then the very first thing you do is you run this endpoint setup command. So that creates the endpoint. And some of the things that you have to specify here, I've got the bare minimum here. Arguably the most important is this this owner option. So the owner, as the name suggests, is the identity that owns this endpoint and has sort of rights to do pretty much anything on it initially. So this must be an identity that's already known to Globus. So you must have logged in and confirmed this identity. So you must have logged into Globus at least once and said, yep, this is me. So you have a, if you will, a valid account in Globus. And if you do have that, then you can use it. If you don't, it will tell you the identity is not found. You're going to have to go and do that. Oops, I'm sorry, I'll go back here. The second command that we run here is the node setup. So if you recall from my definitions earlier, the endpoint is the logical thing. So we tell Globus, hey, there's going to be a bunch of stuff running here that represents an endpoint that you can communicate with. Then we tell Globus, okay, in this endpoint, I'm going to have one or more servers, one or more of these data transfer nodes. So we need to add at least one. And by default, we would typically add the machine that we're running this on, because that's where most people start. They have their first node, they deploy the software and add that to the endpoint. Very importantly, the stuff in the box at the bottom here. After you run these commands, you will have a file called deploymentkey.json in that directory. Please keep this key safe, treat it as any other secret or credential. It is used by Globus Connect server and will be used by you anytime you want to make any changes to the endpoint. And even more importantly, if you want to migrate and upgrade servers, do things like that, or restore something after failure, you will need this key, this file. So please treat it as you would any other sort of secret and precious bit of data. Okay, so at this point we would have oh, and I should just a quick sidebar here. When you run Globus Connect Server for the first time, and you run the endpoint setup command, it actually talks to the Globus service, specifically to Globus Auth, and it registers a Globus client. Essentially, it registers the endpoint. It says, hey, you're going to have a client here, a Globus Connect server. And this gets done inside of what we call a project. So this project is just a way to organize and control access to who can manage the credentials that are used to work on that endpoint. So that'll get created for you if you don't already have one, if you've never installed Globus Connect Server or haven't created any other Globus Auth clients. You can go look at this under the settings developers tab. If you've ever interacted with Globus Auth for endpoint setup, or maybe you've registered a client application, you will already have a project, so it'll usually just pick up the one that you have. If you have multiple, it'll ask you to pick one. Okay, so after we've run those two commands, the endpoint setup and the node setup, we have an endpoint with a single node. And if we want to do this and set up multiple nodes, we could run just the node setup command. We could install the software and run the node setup command on additional data transfer nodes, and those would become part of this logical thing we call the endpoint. So the very next thing is to create a storage gateway. So this command shows how you create a POSIX storage gateway. I mentioned earlier the storage gateway is the thing that is really the interface to your specific type of storage. So POSIX is the default. That's where we all start out typically. You can have different types depending on which connectors you have access to. So this command creates a POSIX gateway and says that any collections or any data access that's going to occur through this gateway will only be allowed for users that present an identity from, or authenticate with an identity from this domain. You can specify multiple domains, but that's the bare minimum. You must tell Globus what identities are acceptable, if you will, by the storage gateway. And then you can see here, I've set a timeout. In this case, I'm requiring the user to re-authenticate once a day, every 24 hours. You can set that, as I said, the default's 11 days, but you can set that to different values. So I just want to spend a minute talking about this mapping thing. So when a user logs into Globus, let's say I log in with my uchicago.edu identity, and then I try and access data, when Globus talks to the storage gateway or to the collection, and then in turn the storage gateway, this mapping happens where by default what it does is it takes the Globus authenticated identity. So in my case, it would be vas@uchicago.edu, and it strips off the domain suffix, and then it's left with vas. So I would need to have an account. There would need to be an account called local account called vas on that storage system in order for me to be able to access data. That's the default behavior. You don't have to do anything to enable that, but there are many other ways that you can facilitate this mapping process. We've got an entire mapping service that runs sort of in line here. There's lots of documentation on that, and that'll be probably covered in our advanced session at GlobusWorld. The other thing we can do at the storage gateway level, which I'm not showing in this command, is we can restrict what parts of the file system are accessible using the restrict paths option. So by default, I think I mentioned earlier, the user will have access to anything that they already have access to via other means, unless you explicitly restrict it using restrict paths. And then this is where, again, if you did have uh, restrictions or protected data requirements, or you had sensitive data that might be accessed through the storage gateway, you might want to require that the user authenticate with multi-factor. So once we've done that, we would have a storage gateway that gives us access to, let's say, some POSIX file system. So now we get to so everything that I've talked about so far are things that the the system administrator, you as a sysadmin, would do, and the user is not really going to ever really see this or interact with any of these things that I've talked about so far. What they will interact with is the collection. So this is one of the simplest ways to create a collection. Collection create. You give it the storage gateway ID that we just created. You tell it where the collection will be rooted, if you will. So if I just put slash in this case, it will actually by default route it to the home, the user's home directory. But you can route this anywhere. You can say, I have a collection, I have a set of data that lives at /mount/projects. So I can have a projects collection, and that would be the root. And then you have to give it a name. And I think I just said all this. It's really important to be aware of this this base path, or this root directory, this virtual root, if you will, especially when you're sort of troubleshooting things. A lot of times we see permission issues because you may have thought you rooted it at a certain point, and you may think the user or the user group has access to that part of the file system, but they might not, or you might have the roots backwards or something like that. So this is just an area to be a little bit sort of careful about. So once we have a mapped collection, then we can access the storage system through Globus using our local accounts. And that was demonstrated earlier by Bridget and by Greg. So this is what it looks like. Now we've sort of moved all the way up through the stack. We created the endpoint, added one data transfer node, added a storage gateway, and now we have a mapped collection sitting on top of that storage gateway, if you will, for accessing data. Let me pause there for a little bit and see if there are any questions. I've thrown a lot of stuff at you. So that's essentially it. I mean, if we could literally stop here, you could go off, and if you've never created a Globus Connect server, just through those 4 steps, you could have things up and running and have your users accessing data. But let me pause there and see what questions folks have, if any.
Vass, we've been keeping pretty well up to date on the chat.
Okay. All right. So let me then continue with configuration. So we've
So
got
just a quick question about terminology here.
Yeah.
So the node is an actual server. The endpoint is sort of logical abstraction over multiple nodes. But then we have the storage endpoints that could have access to different kinds of storage.
Yes.
And I saw in the diagram that the connector is installed on the node itself. So what happens if I have one node with access to AWS S3 and another one doesn't, and then in my storage gateway I want to have access to AWS S3? Well, now it will only route through one of the nodes, or same thing for POSIX?
So all of the storage gateways take advantage of all of the data transfer nodes. So I've shown it sort of each thing sitting on top of one other thing, but the endpoint is sort of the umbrella, and under that sit these storage gateways. Sorry, and under that sit these data transfer nodes. Any storage gateway that you create will use all of those data transfer nodes. And if you have multiple storage gateways, so one pointing to S3, one pointing to local POSIX, they will all use all of those data transfer nodes underneath.
Okay, so the connectors, I can think of them as pooled for the storage gateways. If only one node happens to have access, then that's the only node that will be used. But otherwise, the gateway doesn't even know what nodes are giving it access.
Yeah, so if you if you've restricted the node, let's say through network access or something, then so what'll happen there is the user experience will probably be not so good because Globus Connect server doesn't know what your network routes look like across the WAN. So if the request comes in and it gets routed to that data transfer node, which just happens not to have access to that storage system, the user will get in some kind of error. So that's where we, ideally say that you should have a uniform structure such that your data transfer nodes have access to all the systems that the storage gateways are exposed into Globus. If you wanted to segment that, then by all means, you could have multiple endpoints and sort of segregate your data transfer nodes across multiple endpoints, where one endpoint has data transfer nodes that are, let's say, for cloud systems access, and the other endpoint might be for internal access. And actually, we see that kind of setup fairly regularly. Also for archival is another example where you might want sort of a separate stack, if you will.
Got it.
Did
Thank
I
you.
answer the question?
Yeah, thank you.
Okay. Okay, cool. So let's talk about configuration options. So there are, I don't know, I haven't counted recently, but we keep adding. There are many, many, many options that you could configure up and down that stack, from the storage gateway to collections, etc. I'm going to talk about the ones that are arguably the most common. So I've already mentioned restricting access to parts of the file system. So I'm going to talk about that. I'm going to talk about how you restrict sharing, how you enable and restrict sharing, and how you enable access via just the browser without using the grid FTP transfer protocol. And then I don't think I'm going to talk about channel encryption, but we can talk about that as well if you like later on. So the first is restricting which users can access data. So as I said multiple times already, I think any user that has a local account, when you create that map collection, can access the data that they have access to. You may, for some reason, this is fairly rare, I will note, you may say that only certain users can access their data through Globus. So for this specific storage gateway, let's say I put users in a special group that says, if you're in this group, you can access data via Globus, otherwise you can't. And again, this is all applying to map collections only because we're talking about local users, local POSIX users on the operating system, or POSIX groups. Again, a rare scenario, or relatively rare, but I do need to mention it because some people have these kinds of access restrictions. The other dimension you could restrict access on, as I said, is the path. So you can say, I want to enable Globus access on everything that the user has access to, maybe except archival storage, because you want to have some other way of users putting their data into your tape archive, for example. So you would do that by using the restrict paths option. When you create that storage gateway, you use the restrict paths option to say specifically what paths in the file system the user has access to, either read or read-write access, or none. So you can also explicitly deny access using that option. Okay. So all those things you can do without having a subscription. You can set these restrictions and have data transfers running. No worries there. The next set of configuration options that I'm going to talk about have to do with things that do require a Globus subscription. And so in order to enable these things, you would need to subscribe your endpoint. So the way we do this is, once you sign up for a Globus subscription, you get a subscription ID, and that identifies, that's sort of a group within Globus, a special type of group that tracks who's part of that subscription in your institution. You can have, as in that group, you can have managers, these subscription managers. You can have multiple of them, and each of them are able to manage resources under that subscription. By default, any member of your subscription can manage their own resources, but the managers are typically the system administrators that are able to manage multiple endpoints perhaps and other resources under that subscription. So the first thing you would do is you would associate the endpoint with a subscription. So that makes it what we call a subscribed endpoint. You'll sometimes hear the word managed being used. That's sort of a legacy term. And this is the very first thing I would do after doing this is to actually grant access to others in my organization for the purpose of administering and managing and monitoring and so on. I'm going to talk briefly about roles, I think maybe on the next slide, but this is a really important aspect of having a subscription, is that you now have much more flexibility about who can manage your configuration. Okay, and I think I already said this, that as a member you can subscribe your own, subscription managers can subscribe any endpoint. So if you want to see, if you're not sure whether your organization has a subscription or whether you're a member, you can go to settings /subscriptions, or go to the subscriptions tab under settings. You'll see if you're a member of any. If you're not, you can search for your organization and see if they have a subscription, and you can request to join that subscription. Okay, so it's pretty straightforward to associate an endpoint. You can also do this through the web app, through the console, but you just run this command: endpoint set subscription ID, give it the subscription ID, and then your endpoint is subscribed. Okay. So a quick word on these roles and identities and so on. So the first point is that only the owner can do that initial configuration. Once you've done that, then as I said earlier, I strongly suggest that you add additional administrators. So you grant the administrator role to other folks in your organization. And the best practice there is actually not to grant it to individuals. It's actually to create a Globus group and then grant that group administrator access. And then as people come and go or change their roles within your organization, their positions, I should say, they can assume or be removed from that role by virtue of their membership in that Globus group. So you can just add and remove group members without having to worry about individual names. I am going to skip that. You can read the rest of that stuff. I'm going to talk about the next most important thing that a subscription enables, which is that you can enable sharing or the creation of guest collections. So by default, when you create that mapped collection, it does not allow guest collections. Even if you are on a subscribed endpoint, by default, sharing is turned off. And you need to enable it. And as a system administrator, you need to run this command. So it does an update on that map collection and just tells it to allow guest collections. So you just provide that flag, and it allows guest collections. And again, you do this as a sysadmin, but the guest collections themselves will be created by the user. Okay. And as we've said a few times already, you create the guest collection to grant access to other Globus users who don't have a local account that they can be mapped to. Okay. I think I've already said this, but it bears repeating. We are really careful to respect all the underlying system permissions. So the guests, the users that are part of this guest collection cannot do anything beyond what the data creator can do. And the second bullet here is important. We have many scenarios where, we're dealing with sensitive or protected data, and we want to have a much more detailed audit trail of who accessed that data. So by default, when you access data through a guest collection, the logs will show that it was the creator of that guest collection, the owner of the data that has the local account. It'll show them as being the person accessing the data. But if you have a high assurance a subscription and a high assurance collection as a result, we'll also capture the identity of the Globus user, so the actual the sharee, if you will, who actually access that data, and then that's really, really important for auditing. Oh, and this is also very important, is keeping track of where that guest collection points to. So when you create a guest collection, because it sits, if you will, on top of the mapped collection, it's kind of a virtual layer on top of it, the actual path to the storage system is relative to wherever the mapped collection was rooted. So if you had your mapped collection rooted at /mount/data, if you create a guest collection that sits at root, that root is actually /mount/data. Okay, so kind of obvious when you think about it, but sometimes when we sort of look at the interface, we say, oh, this guest collection is showing me at root, but I don't have root access. Well, you actually are rooted wherever the mapped collection starts. Okay. So once you have enabled sharing as a system administrator, you can further restrict sharing on a number of dimensions. So I've got them highlighted in orange here so I don't miss any. First is, just like mapped user data access, you can restrict who can actually share data. So you can create a guest collection and share data only if you are a user in this POSIX sharing group, okay, for example. So who can share, what they can share. So the same way you had restrict paths for data access through a map collection, you now have sharing restrict paths for data access through a guest collection. You can also say how long these sharing permissions will live, or how long they're valid for. This is only available on high assurance guest collections, but that's really important. So you might say, hey, I'm sharing this data for you with you for the next 24 hours. Make sure you download it, otherwise it won't be available. Right, very typical scenario in protected data environments. You can also restrict who you share with, so the sharee or sharees. That's done through a thing called an authorization policy. So you would create a policy, for example, that says this data can only be accessed by users at xyz.edu. So even though I might have get granted permissions to a whole bunch of other users, when a user tries to access data through that guest collection, if I have one of these auth policies in place, it will check to see that the user actually has a credential from xyz.edu. Otherwise, it will not allow data access. And then you can get really, really kind of convoluted here and complex by mixing and matching these users and paths and having specific sharing policies that say user of S can only access or share data from this directory and so on, right? So lots and lots of knobs that you can turn and levers you can pull here. And we've done this to address the very wide range of scenarios that exist out there as far as policies that people want to implement. Again, this can get pretty complex, and we're very open to having you talk with us and get guidance on how you set these things up. Let me pause there and see if there's any questions on the sharing before I move to the next thing. This usually generates at least some questions in people's minds about, is this safe? Is this secure? Am I opening things up to the world? Anything at all? Okay. So the next thing I want to touch on, another common configuration option is whether or not you would like to allow users to just download and upload data from your collection via their browser. So without actually setting up or having another Globus Connect server or Globus endpoint somewhere else, they can just go to their browser, just like normal browser behavior, and say, download this file. In order to do that, you need to update the endpoint and tell it, you need to update the collection and tell it to allow HTTPS access. That's the browser-based access. Important thing here is that this doesn't suddenly open up your collection to anybody who browses to it. This is still authenticated access. So when the user tries to either upload or download a file through their browser, they will go through a whole auth flow. And they need to have permissions on that collection. And typically, this is through a guest collection. Because this is browser-based access, the data download or upload is done using the web server that gets installed on the endpoint. So it's a different application, so it requires separate authentication. We're not actually going through the Globus managed file transfer path, which uses grid FTP and all of that. But it uses the same authorization layer, the Globus auth service, to ensure that all the permissions and restrictions and so on are enforced. Okay. Oh, and even though the collection, the HTTPS access is enabled at the map collection level, you can have guest collections that sit sort of on top of that, have their own flag on whether browser access is allowed or not. So you can selectively enable or disable it for guest collections. Okay, that's pretty much the very summary version of the things you can do to configure. As I said, there are many, many options. If you look through the docs, hopefully you'll be amazed, as I am every time I look, because we keep adding them. But they're all useful things depending on what you're trying to do. Again, I encourage you to come to the deep dive at GlobusWorld, where you can learn and ask more about some of these things in depth. So the last section I'm going to go into is operating Globus Connect server. So you've installed this thing and it's running. So what are you actually, what do you need to do beyond that? Hopefully the answer is nothing or very little, because we hear from folks, and we're very happy to hear that it just works once it's installed. It just runs. But certainly you might want to be doing things like monitoring who's doing what with your endpoints, what transfers are running, and you might want to pause the environment to, let's say, do some maintenance or something that requires urgent attention without breaking everything that's going on. So we have the ability to let you do that. And you can create these things that we call pause rules. They allow you to pause the endpoint for a certain period of time and then resume it. So all the activity gets paused, and the transfers will pick up where they left off when the endpoint was paused. In fact, it might actually be worthwhile just to quickly show you this. So let me just swing over to a browser here briefly. Might be nice to actually show you something other than slides, I realized. So this is me in the web app. You've already seen this. So the console that I'm talking about is here on the left. You'll see the console link in the nav bar. So when you click on that, I have access to a bunch of endpoints. So you'll see activity that's going on your endpoints here. You can drill down and see specifically things that might need attention. You can see the type of error that's going on. So this is Globus doing its normal thing, right? So it's transferring data and then something failed. It did the checksum to verify data and it failed. So it's going to retry that and so on. And here are the pause rules that I mentioned. I don't have any pause rules, but I could create one that says, take this endpoint and pause it, etc. And while I do some maintenance or what have you. And this is also where you can see all of your endpoints. Again, this is a subscription feature, so you won't have access to any of these pages unless you have a subscription. but you can see your endpoints. So I'll just click on one of these. I have a few endpoints that I use for demonstrations in the cloud. So this will give me some details about the endpoint. This is the same information that I can get via the Globus Connect Server command line interface. But this is just sort of a nice way for me to browse it. So I can see, here's my endpoint. This is the address at which, or the DNS name at which the Globus Connect Server manager lives. So that's how Globus, the service, communicates with that endpoint, is through that URL. I can see if others have access to manage this endpoint. So this is really my own demo. So I have just myself, and I also have some service accounts. We haven't talked about that, but we can if people like at some point, and so on. So I can see the storage gateways, nodes, etc. So to the earlier question, as an example, I have a single endpoint on AWS, and it actually acts as a storage gateway to multiple storage systems, including things like Dropbox. So we have a Dropbox connector, and I chose to run my data transfer nodes that access Dropbox on AWS because Dropbox doesn't have its own sort of compute or server service. So I run EC2 instances on Amazon. They access lots of S3 buckets. You can see the S3 connectors are being used for those, but they also access my Dropbox collection. Okay. And this endpoint has 2 nodes, so I can go look at them. They're both in service. Everything is great. And then I can also drill further, or sort of go further up the stack. I need to re-authenticate just so I can see all of those collections that I have. Ooh, I don't know why I'm being prompted to go in through here. I'll tell you what, let's not do that. But you can see all the collections that sit on top of the storage gateways on that endpoint. So you get a complete picture via the console. Okay, I'm going to switch back to the slides and just wrap it up here so I can give Lev his half hour. So logging, we do have extensive logging, and you will probably want to look at the logs at some point for troubleshooting or other things. There are some default logs that get created. So the Globus Connect Server Manager, the thing that I've been talking about that we're using to manage the endpoint, it logs its activity to a log. The data transfers themselves are logged by GridFTP to this GridFTP log. And then if you have HTTP enabled, those transfers get logged in the Apache logs because, again, they're going through the web server. If you have a high assurance endpoint, the more detailed audit trails that I mentioned, those logs are kept in yet another set of log files. Okay, they're gridftp-audit. And most of the logs are set to be relatively terse in their logging. If you want to make them more verbose, you can change the log level. Just a warning, if you set it to all, especially for GridFTP, you will get very, very large log files. So be warned. Sometimes we ask you to do that if you have an issue, and the support team will tell you to turn it on and run it for a little bit so they can see in greater detail what it's actually doing. But in most cases, you'll want to keep it at some level that's less verbose than that. And anytime you change these options, you do need to restart that GCS manager service. All this is described in our documentation. I'm just giving you a flavor of what's available so you know where to look. And then finally, I think I'll just mention troubleshooting. If you run into any issues and say, oh, I'm going to email support, which you absolutely should do. And Greg said, I will second that. Our support is amazing. The first thing they're probably going to ask you to do is to run the Globus Connect Server self-diagnostic command. That gives you and them a bunch of information about the different services that are running on your endpoint, what their state is, and potentially if there are any errors. So that will sort of start pointing the way to where the root cause is. And in many cases, the root cause is connectivity. So proactively, you should probably check can I access this node from the outside? So in turn, can Globus sort of connect to it, right? Is the control channel reachable through my firewall, et cetera, et cetera? We have tests for doing that. We have a whole troubleshooting guide that can walk you through some of those things that you can sort of do yourself before reaching out, but by all means, do feel free to contact support. Okay, I'm going to leave it there. I will pause for questions, and if there are none, I will let Lev take over. Okay. Thank you. I see lots of chat activity now. That's great. So Lev, over to you.
All right. Getting everything settled here. Sorry about that. Okay, and now I need to share my screen. Where's the button? Hope it's on. So now we're switching gear completely. We go to Globus compute territory, and our colleague Buzz likes to start his talks with a joke, and then so I'll follow the suit. And what's the joke is, what's the difference between Globus transfer and Globus compute? And the answer is Globus compute doesn't. But it enables you to run things on your infrastructure, compute tasks on your infrastructure, just like Globus transfer allows you to run Globus transfer tasks on your infrastructure. And I'll be doing this parallel fairly a lot throughout this talk. So you've seen this picture a lot of times today. This is what we're going to focus on: managed remote execution. So that's a service that enables programmatic access to compute resources with the function as a service model. There is a service that orchestrates that you can talk to, you can send tasks to it. It relays those tasks to your compute infrastructure, which is presented and abstracted in this in the uniform way. You get consistent, just like with transfer, you get consistent user interface across different resources. And resources, it can be, it can be a local, a single server with a local process pool, or it can be a Slurm cluster, or a Kubernetes cluster, or PBS, whatever you need, deployed on laptop, desktop, cloud resource, supercomputer, whatever. That all looks the same and can take tasks. So why should researcher use Glue? The familiar tool, they use Jupyter Notebook or Python scripts, and they just offload the computation. They can reliably manage repeated tasks, like parameter sweep, Monte Carlo simulation, all of that, from the comfort of their own laptop or Jupyter Notebook. If you have access to multiple computing resources, great. You can run things on all of them. You can scale out. You debug on your laptop. You send the big thing to leadership class machine and everything in between. You can use compute steps in automated research pipelines. So both data management and computation, we've talked about flows. Compute steps can be part of it. And the idea is that, and I cringe when I say, well, no, you're a researcher, you don't need to learn anything. Well, yes, you do, but not as much, right? But you can hide a complexity of the HPC system from the researcher. Someone needs to know HPC. Yes. Someone needs to help setting up, define the proper parameters for invocation. But once that template piece or set of settings is defined, they can be passed along to the researcher, and the researcher plugs them into their script and runs and doesn't need to learn anymore, doesn't need to SSH anywhere, and all of that. So the gist of it, we define Python function just like any other code. We run functions locally. Well, not the functions, the script, the top level script runs locally, and then it runs the code on the compute resource, and it's a Python future. You wait for the result. You can block or not block. You can access results later asynchronously. Again, repeated task management. You don't need to log in and dwell on the login node. You don't need to SSH there. You can do everything from the comfort of your laptop, and tasks are outsourced and sent away. In certain failure modes, they are retried, and certain they don't. But in any case, you get you have the entire list of your tasks and their statuses and everything. And no special tools to access any compute resources, but you just run the Monte Carlo. Or if you have something that you need to do every day, a weather forecast nightly, wrap it. You run it all the time, every time with the same setting. Wrap it with in a compute function, and have it executed. Better yet, make it a flow, and and set it up as a timer. Here's an example that's been done. I think it's at Argonne. Feedback with, again, bag of tasks with AI in the loop, where you do, you have a model predict some things, then you run simulations on those subset of predicted things, extract information, feedback to the model, and then get a new and better prediction from the model, and you repeat that. This can be a flow with a human in the loop, and obviously compute steps. And the huge advantage is it simplifies the execution on different systems. You have a count of, again, your laptop, your cluster machine, campus cluster, leadership class machine, access resource, anything. Everything in Globus is a UUID, right? So yes, there is a compute endpoint on the campus. There is a compute endpoint at Purdue on access, and today you need something bigger, so you just change the UUID of where you send your task. You will need to set up runtime environment on different settings. So you cannot completely avoid logging in, but once that is done, it's just a flip of the switch inside your top level script. And
excuse me.
Yes.
Can you please go to the previous slide, please?
Yes.
So do we have to do the imports inside the function here?
Yes, and I was going to talk about it later, but yes, the import needs to be inside the function, because what happens is the function gets serialized and sent to the resource and deserialized on the other end. So yes, you want to include whatever the function needs in it. There is a new development, and I think my colleagues in the chat might have thought there is a way of actually sending code rather than actually serialized version of the specific function. But that's new. Well, no, for current standard practice, yes, you want to include all the imports inside the function. Make it self-sufficient thing.
Okay, but will this change, you mean?
No, no, no. It will still be the same. This is still an available method.
Okay.
There will be better I won't say better, other methods as well. So you'll have more flexibility, not less.
Thank you. Okay.
And again, compute steps can be incorporated in the flows. They can do actions that don't have action providers in the flow. For example, you want to tar your a bunch of file before you're sending them to tape archive. Just bundle them. Globus transfer doesn't have an ability to bundle before sending things, but compute can, right? So you can have a compute endpoint on right next to your source data, and then make it a flow that will just first tar and then send it to where you want it to send. And you can do it manual, automate the execution. Lots of flexibility. For example, there can be multiple compute steps in. This is an actual existing flow in serial crystallography. I think it's at Argonne as well. There is acquisition. There is a compute step to launch a QA job, just to see, oh, did we acquire good? Good. Human in the loop says, okay, yeah, this looks good. Send it. It gets sent to an HPC resource to analyze images and process and then do some visualization and then extract metadata and so on and so on. So you can run something on the server, single server and immediately adjacent to the acquisition, then the supercomputer, then the GPU cluster, then a separate task, without the GPU. Lots of flexibility. So the components, as just like you've seen in many in transfer, the components of Globus Compute, there is a service that we run that everyone clients talk to. There is a compute endpoint. It's a piece of software that you deploy on your resource that abstract access to this resource and presents it, makes it visible in the Globus Compute ecosystem, just like transfer, Globus Connect server. You deploy it, and it makes your storage resource visible in Globus transfer ecosystem. And we have a compute SDK, which gives you an interface for interacting with the service. And how it looks from the researcher standpoint, it's so here is a research. Here's a researcher. Here's a Globus servers. Here are the two compute resources A and B, and researcher. You register your code as a Python function, and again, it's a Python function, but it can be as complex as running an LLM, or as simple as sysexec, your bash script, and anything in between. Then once you have a function, and registration can be permanent in a sense that you register and get an identifier, or it can be a transient. You say, well, I have a function, just run it. A transient identifier will be generated and register for short-lived. And then you say, I want to run it on resource A and B. Globus service sends the talks to the resources, tells them, well, I have a task for you. Prepare to run. They prepare, they run, they send the results back. You get the results, and small results you immediately, you can get the results, or you can wait and retrieve them later. If they are small, you can actually get them. If they are not if they're large, you probably need to write them in the file and then separately transfer them out. But the gist is, you ask Globus service to run something somewhere, it does, and it returns. So that's from the researcher. And if you need to run on the third resource, you just switch the UUID for that destination. From the administrator, right? You have your HPC, your compute resource, cluster, server, cloud, whatever. You deploy a Globus compute agent, to make it a Globus compute endpoint. So Linux only. We have packages for major distribution. Very similar to the case of Globus Connect. They can be multi-user endpoints and single-user endpoints. They behave this almost identically, and it's the same software, just two different modes of operation. I'll show it in a sec. But if you choose, so for example, on the campus cluster or like shared resource, you probably want a multi-user endpoint, just because multiple users. If it's a single instrument in the facility or adjacent, like nearline machine, might be a single user endpoint for more limited processing. You configure the executor template, whether that's a Slurm, this is a PBS, whatever your scheduler, or maybe it's a process pool. Just run it. When the task comes, run it. You as an administrator, you decide what you want to fix and what you want, or what you don't, what you want your user to be able to change. So there's lots of flexibility in control, and specifically, if it's a multi-user endpoint, you will need to configure identity mapping, just like you did with Globus Connect. If it's there has to be a mapping from incoming requesting identity in the Globus LAN to a local user account that will be executing tasks. And you have lots of control. You can map everyone as they are. You can say, well, I'm only going allowed to this and this and this person and nobody else. That's all up to you. If you have already an installation of Globus Connect, you can use that very same map. So the two modes, in single user mode and multi-user mode. In single, it may be easy if we look at the multi-user mode first. So it's system-wide endpoint installed by sysadmins, right, from packages. The core process, the endpoint, the listener, here, this runs as root. When the request comes in, it performs identity mapping, forks, drop privileges to that local user, and starts a transient user endpoint process as that user. This transient endpoint process then connects to the Globus to the compute service, says, okay, I'm ready, send me your tasks. The tasks comes in, the user endpoint process forks spawns workers, which go through your cluster, your scheduler, into the queue. So spawns a job, the workers run inside the job. The single user mode is exactly the same, except one little thing, it's already mapped. It runs as that user. So the listener process runs as that same user. There is no ID mapping. It still forks the transient endpoint process, and and that's it. And the reason we do it is because configuration is templatable. So as I mentioned, there are things that you can restrict and things that you can allow users to specify. For example, if you have a scheduler, right? User needs to supply a Slurm account to run under and maybe a wall time. That much you allow them to change and actually require them to specify. Everything else you want to fix, like all these jobs will only go into that partition. You fix that, but you give them the flexibility to specify their value. And when the user endpoint processes spawn, it combines the incoming request settings with what you specified in the template. It processes and populates the template and runs and then runs it. So let me try to do a demo, and it's as always. So here's my laptop, and I have a simple Python script that just here's the function that I have. Sum the numbers that I give it on the command line, and print the host name. So with that function, I create the executor, and I submit it, and I wait for the result. And if certain endpoint, I may on the fly, I may tweak the settings of my executor on the fly, depending on which endpoint I send it to. That's important. Again, someone needs to know this, but not everyone needs to know it. That block can be specified, developed by Lab Guru or one of you, and given to a user, and they will be just happily using it. So let's, for a simple first thing, I'll do. Let's run it on the endpoint that we ran, the Globus tutorial endpoint. So I will need to activate the compute environment, and oh, wrong. I need to give it parameter, something to run on. Okay, I got my 15 and the weird host name that the thing is in AWS. Now, I happen to have a Globus compute endpoint on my own laptop, so I will just see. Okay, it is stopped, and I want it to start in detached mode. So it's okay. It's running, checking list. Okay, it's running now. I just change that and send it to my laptop instead. Great, live demos. I swear it worked yesterday. All right, well, while we're waiting, let's go to actually set up the entire, maybe my home network is misbehaving. Oh, yeah, no. Okay, my laptop is just being slow today. So now I got the response, and note, notes a different host name. Okay, now I need to scale to a cluster. I have access on Purdue Access Anvil system. I'll go there. I'm on Anvil, login 02. So I want to set up from afresh a Globus Compute endpoint. And we were thinking about demos, normal demos. We would show how a system administrator would deploy the packages and do what. But I think in kind of to convince you that you probably want to deploy packages and make it centralized, I'll show you, try to scare you how easy it is for the users to do it. So maybe you should lead that rather than allow users hijack it as they want without any restrictions, because when you set up the endpoint, you control what they can do. When they set up the endpoint, they can do anything their normal user can. Zero restriction. So setting up the execution environment, I need to module load conda create. I don't know. I create the environment. Should be quick. All right, environment created. And activate. All right. And now I want to install Globus Compute Endpoint. Okay, it is installed. Now that I have the command Globus Compute Endpoint, or short GCE. Configure. I give it the display name. Okay, everything is in .globus compute in my home directory. When the things I installed centrally, everything in .globus compute under root. So let's go there. So we have 4 files, and the endpoint config, the user config schema for the and user config template for that spawned user endpoint process, and optionally you can specify additional environment variables that will be injected into running endpoint in the user endpoint process, and the tasks. You can specify them separately in a separate file. If this was a multi-user endpoint, the difference would be I would just give -- multi-user, and there would be another file, the configuration file for the identity mapping, where you can define. But this is a single user mode. No mapping is needed. So let's look at them. Right now, in the config YAML only has the name that I specified. I can specify subscription if I have a subscription. I can specify multiple administrators if I have a subscription. The config schema right now is very simple. You can add more. The configuration by default with we throw local provider which is a process pool, which is what I had on my laptop. I don't want to type things in by hand, so I prepare and the environment variable is simple. So I have prepared a simple Slurm configuration template file for a Slurm provider on Anvil. We have examples on the website. In the documentation, we have example for multiple systems. Chicago, several access system, Anvil, some National Labs machines, which you can use and change and tweak and modify to your liking. So I'll just copy that. Okay, so Smodrem, let's look at what do I have in terms of endpoint? I have one standalone single user endpoint, and now I have this GlobusWorld demo that's initialized, but it has never started, so it doesn't have a UUID yet. So GCE, start, detach. Okay, and if I do now, I get the UUID, which I will need to enter in my script. That's the one. And now I want to run on Anvil. And I send that, and meanwhile, on Anvil, I do what I know you all dread, and I'll start watching the queue. Here it is. The worker has been sent, the user endpoint process has started. It sent a pilot job. We're waiting in the queue. Hopefully we'll get there soon. But that's about as easy as it is. Oh, it is running. Okay. Hopefully I should get the response here quickly. There. Now it ran on the Anvil compute node. I will not pound the SQ. No, the job is still there. So the second task should go much quicker. I don't wait for, see, I'm getting the result. It went and came back. And I can have that pilot run as long as I need. All right. Notice the serialization warning because it's an issue. We have several strategies to deal with it, and they're well described in documentation. We'll talk about that in the deep dive. But for now, I'm lucky that's a simple function, and it worked well anyways. All right, so going back to my slides.
Lev, just a quick time check. We're just past time.
Yep. So the benefits of multi-user deployment for clusters, right? Researchers don't need to log into the terminal. They don't need to run long process on login nodes. You can nip that in the bud. As administrator, you lower the barriers for your users. You control what can and cannot be done. You have a lot of flexibility in the identity mapping. And you can apply whatever authentication authorization policies you need. And again, you don't have long-running user login processes on login nodes. So we've covered that. Here's the resources. That's important. We're getting started. We have a Jupyter demo, Jupyter Hub instance where you can play with this. There is a notebook on Globus Compute Introduction. The documentation site with Quick Start, the sample templates and configurations for different resources that you can use, all there. Oh, I managed to duplicate the last item. Okay. And really, 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 if you ask us for help, we're here for you. We can talk about best practices. We can help you being sounding boards for your designs. We can assist and help. Just please reach out to us. And with that, I will.
Excuse me.
Yes.
I have a question. So if, let's say, for example, there's an LLM job running on the HPC, and I want to send a query through Globus Compute. And can I get the response back token by token in real time, or does I have to wait for the whole response to be generated at the HPC and then I get back the full response at once? I mean, like, does Globus Compute work? Does it does it respond back partial answers, or does it have to wait for the full thing to finish and then respond back?
Well, the function need you send the function needs to exit
Yeah, I mean,
successfully or unsuccessfully, and then you get the response. I don't know. No, I
I
don't think.
see. I see. Okay.
Now, Globus streaming that has not been covered has been mentioned. Globus streaming actually can allow you to connect two applications through a secure tunnel, which can be an answer to your question, but that's a different story.
I see. But can I send functions through Globus Stream as well? Or like query or anything like that, similar to Globus Compute?
Well, the way Globus Stream works, it really creates a secure tunnel between two applications in a different system. And so once that tunnel is established, basically instead of transferring files, the application writes to a socket that gets redirected through the tunnel to another application on the other end of the tunnel, which can take it, read it, process it. So yes, you can run LLM in one enclave and query it from another enclave through the tunnel.
I see. Okay, thank you. Thank you so much.
Yep.
All right. Well, I see we're just a little past time, so thanks everybody for joining. Thank you, Lev and Vas, and we look forward to seeing many of you at our in-person conference in Chicago. Thanks all.